Hello, everybody, and welcome to part 4 of the Commerce Extension series. Today's topic will be a deep dive on Commerce Extension packaging and Azure DevOps Build pipeline setup. My name is Emily, and I'll be your moderator today. We are broadcasting this session through Teams live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to this experience. The recording will be available on the Tech Talks Community Dynamics page within 5 business days. If you have questions for the presenters or need support, please use the Q&A panel located on the right side of your screen. Our presenters will be responding to your questions throughout today's presentation, and there will be time at the end for further questions. Thank you for your patience during these announcements. Presenting for us today from Microsoft, we have Muganthan Mani, Senior Program Manager. Muganthan, over to you.
Thanks, Emily. Hey, thanks everyone for taking the time and joining the session. In today's session, we'll do a deep dive on how to set up the build pipeline for your extension and generate the output build artifact. So we'll do a deep dive step by step of how we're going to set up the build pipeline and how you can generate the different packagings. Okay? So with that introduction, let's get started. Okay, so the agenda for today's session will be first, we'll cover what are the different packaging types. So for example, you would have done Commerce Runtime extension or the point of sale extension. So you may wonder like, hey, what are the different types of packages I need to create based on my deployment topology? So we will do a deep dive on what are the different packaging types at a high level overview. First, we'll talk about overview. Then Luke will do a deep dive on exactly how to generate those packages. Okay, so first we'll start with overview, then we'll cover like how to generate those packages. So after the package generation through Visual Studio, now say you want to do everything through the build pipeline, right? So we will cover that, like how you can do the packaging through build pipeline. And also one important topic we'll cover, like, hey, so now say, for example, you have a package from your ISVs or from your different partners or like from the customer. So we'll also talk about like how you can merge different packages. We'll also cover like what packages can be merged or what packages suppose like multiple different packages where you don't have to merge. Okay, and then after that, we'll also cover like how you can sign the packages. Say, for example, some organization will allow only like trusted packages to run in the system, right? When I mean like installers. So we'll also talk about like how you can sign the packages using the build pipeline using the Azure, for if you want to store the certain like in Azure keyword, like in a secured location. So we'll also showcase like how you to set up the certificate in Azure keyword. Okay. Then the other one important topic Luke will cover is like how to set up the PS27 build agent for MPOS, because starting I think sometime next year, like March, if I remember correctly, March or April, the build agent is getting the VS27, the VS 2017 Win 2016 build agent is getting deprecated in the Azure DevOps pipeline. So for MPOS, you may need the VS 2017 agent. So Luke will do a deep dive on how to set up that agent here. Okay. With that introduction, let's get started. Okay. So first I will show like what are the different packaging types, and at a high level over it, then we'll have go a deep dive on different packaging types. Okay. So basically there are two types of packages at a high level. I'll say the on-prem packages and then the cloud packages. So the cloud is what it's managed by Microsoft. Okay, so like you go to the lifecycle service and then deploy a production environment, right? Or like the UAT test environment, which is managed by Microsoft. Okay, so there are some packages which goes to the cloud. So if based on your topology, if you say like I'm going to use the cloud scale unit deployed by Microsoft in cloud, then some of your extension package must go to that cloud scale unit. Or based on your deployment topology, you can say like, hey, I'm not going to use cloud components. I'm going to use the on-prem CSU, basically the same CSU, you're going to install it locally. Or also the other channel components like modern point of sale, hardware station, which you will locally install, right? So from on-prem, there are like three main packages. One is the cloud scale unit self-hosted, we call it as, where instead of cloud, you're going to install it locally. So it will contain your Commerce runtime extension, your database extension, the API extension. The next slide will do a deep dive on what all the different components, but this is like the one first main on-prem component where you can do a CSU self-hosted. Okay. Then the other main on-prem component is the modern POS installer. There is like we have like two different flavors of the point of sale, right? One is the cloud point of sale, other one is the modern point of sale. So the cloud point of sale is deployed to the cloud. The modern point of sale is where like you install, basically you take the installer and then you install it locally on your machine and then run it. That's the other on-prem installer for modern POS. Then the last one is the shared hardware station. For Cloud POS, if you want to set up hardware station, you can install the shared hardware station locally. So you can generate separate installer for the shared hardware station. So all the yellow box here is kind of your extension, and the top blue box is kind of the out of the box core installer. Same with the cloud. In the cloud, basically there is two main things. One, your Commerce runtime, and then the APIs and database extension, and the other one is the CPOS extension, so which is packaged and deployed to the cloud. So based on your deployment topology, you can generate packages for this and then deploy to the cloud or to the on-prem. Yeah. Okay. So with that overview, so we'll do like a deep dive table of what are the different packages type. So for cloud, so we have the only one package type called the cloud scale unit package. Okay. So which can contain your CRT API database and the CPOS extension. Okay. So this package is uploaded to the LCS and then deployed to your cloud environment managed by Microsoft. Okay. So in this case, this one doesn't support multiple extension packages. So if there is ISV package, or if there is like another extension from a different partner, or like the customer extension package, all those packages need to be merged and then deployed as one package. So for the cloud, currently we support only one pack. In the future, we want to support multiple packages without merge. But for now, you have to like merge all those packages and deploy as one package. So, but Luke will cover and show like how you can merge the packages at build time in an easier way. So you don't have to worry about like, hey, I need to take those packages, understand it, and merge it, right? We'll show you like how to merge it at the build time. Okay. Then, so the other one is the packaging project package type, how to generate it. So we'll do a deep dive on how to do this one. Okay. Then the rest all is the on-prem. The same cloud scale unit, it's based on your deployment topology. You say like, hey, I don't want to use cloud. I'm going to set up everything locally. Then you will generate the self-hosted package. Okay, basically the installer, which will again going to contain the same components which can be installed locally. Okay, and this component supports multiple installer. Say your ISV can give you a self-hosted CSU package, and as a customer partner, you would have created another installer. So multiple extension installer can be independently installed. You don't have to merge it. So you install the out-of-the-box core installer, then add all additional extension and number of extension can be installed separately. Okay, so you don't have to like merge any packages. So this supports multiple extension package. Same with the modern point of sale. Again, it's going to contain your CRT API database for offline, and then the core UI extension MPOS. Okay. And this also supports the multiple extension. So you can install multiple modern POS installer without doing any merge here. So there will be out of the box installer and multiple extension installer. Yeah. And the last one is the shared hardware station. Again, this is also the third on-prem component, which also support multiple extension installer. So you don't have to like merge it, you can independently install it. So quickly to summarize, three packages for the on-prem. One, your cloud scale unit self-hosted, your modern POS extension installer, and then your hardware station extension installer. All these three supports multiple extension packages, so you don't have to merge, you can independently install and run it. Okay. For the cloud, is the one main package is a CSU, which is going to contain your Headless Commerce API extension, basically the CRT API database, and then the cloud point of sale. Okay, so all these four components as packaged as one zip package and then deployed. So all the on-prems or the installers.exe files. Okay, the cloud scale alone it's like a zip package. Okay, And this is like deployed and managed through LCS, and all the on-prem, it's like an installer, you can manage it on your own. Yeah. So with that, I will hand it over to Luke to show a quick demo on how to set up these packages from code and generate the packages. So Luke will do a deep dive on this.
Okay, thanks, Maganthan. So as Maganthan said, I'm going to give a quick demo and showcase a solution here where we are packaging all different types of Commerce SDK extensions, and we're using all possible packaging options as well as a part of the same solution. So what that means is on the right, you can see here in the Solution Explorer that we have the channel database, Commerce runtime, a hardware station extension here, and then also point of sale extensions. And then on the packaging side, we have the Cloud Scale Unit project here, the Scale Unit self-hosted installer. Then there's also the modern POS installer and the shared hardware station installer. And you can see kind of we have it all modeled in a single solution here, which is a pretty good way to go about that. But quickly, before we go too far, I'll just show a little bit more about our repo structure, starting kind of at the root with the NuGet config file. And so this is the config file that is going to tell us where to get NuGet packages from. I think we've gone over this in the previous talks, but we can see quickly here, there's the commerce feed listed, as well as the public NuGet.org feed. And then for demo purposes later on here, I've also added a local packages folder to act as a NuGet feed. And I'll go more into that a little bit later. So the next key file in the repo is our customization package props file. And this props file is used to share the properties across all of the projects within our solution. So important information like the package publisher, package name, display name, description, all of these required properties that are needed across different Commerce SDK projects are included in this customization package props file. And then we can also see it's importing a repo props file, which is here at the root. And this repo props file isn't strictly required. All of this information could also be in the customization package props file, but separating it out here helps in case that the repo contains multiple Commerce SDK solutions. And so we can see here the repo props file is mainly including information about the build version as well as the package dependency versions that are used within the repo. So that was just a little bit about the repo structure. In addition to those files, we can just see quickly here, there's an individual folder within the source folder for each of the Commerce SDK projects that we have in Visual Studio here. So I'll now do a little bit of a deep dive on each of the packaging project types, starting with the Scale Unit extension installer. So the first key thing to note here is that the output type for this project is set to be an executable with the target framework as .NET 4.6.1. And this is the properties that are required for us to generate the installer executable when this project is built. We can also see here that it is importing and package referencing the Scale Unit installer's NuGet package from the Commerce SDK NuGet feed, and simply adding that NuGet package reference will include the required artifacts into the project so that it'll build and run the installer. Lastly, we can see that it's including the extensions for this extension package through a project reference of the various extension projects. So by adding the project reference for the channel database, the POS extensions project, and the Commerce Runtime project, it'll automatically package those files inside of the installer so that they'll be installed when it's executed.
Luke, sorry to interrupt. Can you just, if possible, can you zoom your Visual Studio, Luke? Seems
sure.
But it seems to be a little small. Yeah. Thanks, Luke.
Is that better?
Yeah, thanks.
Perfect. Yep. So yeah, as I said, the project references are key to include the extensions inside of the installer package, and simply by adding those project references, it'll automatically include the various extension types into the appropriate places when the installer is built. One last thing that I wanted to note in this Commerce Scale Unit Extension Installer project is that we've included the Commerce Runtime Extension Settings item inside of this item group. And so what this is showcasing a feature within the Commerce SDK so that when the project is built and it automatically generates the Commerce Runtime config for the installer, it will now, if we specify the Commerce Runtime extension settings, anything included in this item group will automatically be included in the auto-generated config file. This way, that extension settings option is still available even with the auto-generated config files. Quickly, I'll move on to the Modern POS Extension Installer project. You can see again here at the top, very similar output type target frameworks are all the same for the on-prem sealed installer projects. In this case, we're referencing the installer's Modern POS package instead of the installer scale unit project, but otherwise it's the same. And then we can see here that the Modern POS installer it can reference either the channel database project or the Modern POS JS proj, and it'll package either the channel database scripts or the Modern POS MSIX package. So one key thing here is that we're not referencing from this Modern POS installer to Commerce Runtime or to the Hardware Station project, even though we support offline extensions and dedicated Hardware Station extensions within the sealed version of MPOS, but that works based on the Modern POS app project itself. And so if I go ahead and edit this, we can see that this package will reference those projects, and then that MSIX will automatically bundle both the Hardware Station and Commerce Runtime assemblies into it itself. So it's not a requirement of the installer then to reference them. Reload this real quick. So moving on to the shared Hardware Station extension installer. Again, it's very similar to what we've already seen before with the output type and the .NET Framework 4.6.1 targeting. And in this case, we reference the Commerce SDK installer's Hardware Station package instead. And then you can see there's just a project reference to the project that actually contains the Hardware Station extension inside of it. And that's all the configuration that's required for the shared Hardware Station. Okay, and so saving the best for last, we'll go to the Cloud Scale Unit Extension Packaging project. And so within the Cloud Scale Unit Packaging project, we have the target framework is set to net standard instead of net 4.6.1. And in this case, it's because we're not producing a executable, rather we're just producing a zip file or a NuGet package as a result of this scale unit build. So again, we can see same project reference approach to automatically include the extensions into the scale unit package. And then the package reference down here to the scale unit NuGet package from the Commerce SDK. Notice there's no installers in this package name because it's creating a cloud scale unit extension package and not an installer. So quickly, that's kind of all of the different packaging projects, and walking through it, we can see the common themes are the use of project references to include the various types of extensions into the installer or generated package, and then using the package reference to reference the Commerce SDK NuGet packages that provide the build tooling and helpful functionality there. So with that, I want to showcase a sneak peek of one of the features that we're working on for 10.25, which is to address one of the common pain points we've heard relating to the scale unit packaging and the fact that right now there's only support for deploying a single cloud scale unit extension package, which has so far required a manual merge of the cloud scale unit packages. So what we're working on for 10.25 is the ability to automatically generate a merged cloud scale unit package as a part of the build, and so it can be hooked up to the continuous integration and pipeline runs. So to get started, let me jump over to our store hours sample from the previous tech talk, and for the purposes of this demo, let's just assume that the store hours functionality was developed by an ISV to be included in the customer's package. So the first thing that we're going to want to do here is to set the enable generate package on build property on this project. And this is a out of the box property from NuGet and MS Build to automatically generate a NuGet package when the project is built. So now, as a result of adding this, when we generate or when we build our store hours scale unit package, it will generate a NuGet package in addition to the zip file that it would typically build. So let's go ahead and we'll build that project here. Oop. Got to go to the right directory first. All right, you can see it's building the whole project here. Should only take a couple more seconds. Okay, and now if we go ahead and look at the output from the build here, we can see that in addition to the typical output with the cloud scale unit extension package zip file, it has now also generated this store hours scale unit NuGet package. So what we'll do next is we'll take this NuGet package and we'll go over to our other, let's call it the customer repo here. And we'll drop it in that packages folder that had been configured as a NuGet feed, like I showed previously in the NuGet config. We can see that this packages folder is set up to act as a NuGet feed for us. So we can see that we have a version of 2.0 set on our store hour sample. And so what we do next is we'll go back to our original customer solution. And within the scale unit project for that customer solution, all we need to do is simply add a package reference to include that store hour sample. So if we do that, we can, it's as simple as that. And we can see here that we can also take advantage of NuGet versioning, where we can use wildcards so that if there is an update to the ISV package that doesn't cross a major version boundary, that we would pick up any fixes there without needing to take any manual steps. Alternatively, if that's not required, we can also hard code the value here. So with that added, let's go ahead and make sure that the NuGet packages have all been restored for the solution. Okay, looks like that's all built or all restored. So then we can go ahead and build our scale unit package now. So that's going through and building our Commerce SDK packaging solution. Should be done shortly. Okay, looks like everything's been built. So now if we open this folder and go to see the output of it, we can see in our deployable package, not only do we have the POS extensions listed here for the Contoso packaging sample, but also the POS extensions for the store hours sample are listed here as well. Likewise, we can see for the retail server, not only does the config file contain the assembly for the packaging sample, but also the assembly is added for the store hours sample. So we've merged the retail server config files as well as a part of the build. And we can see that all of the assemblies are here in the bin of this combined package. And to showcase this, we can see the store hours assembly added in the Commerce runtime config as well. So effectively, what this means is that simply by adding this NuGet package reference to our scale unit project, to the ISV scale unit project, the build process is automatically merging all of the extensions for all of the different components into a single package, which can then be deployed to the customer's cloud environment. I think that is all that I have. With that, I'll throw it back to Mugunthan, who's going to walk through setting up the build pipeline automation for the Commerce SDK.
Thanks, Luke. Just a minute, let me share my other screen. Okay, hope everyone can see my screen. Okay, so now I'm gonna talk about like how to set up the build pipeline and sign the packages. Right? So Luke showed you like how you can create different extension packaging projects. Right? Now, and then manually generate the package. So now if you want to automate all this through the build pipeline, so what are the steps you need to follow to set up the pipeline? And then the second important thing is like some packages need to be signed based on some organization needs, or also to secure the packages, you need to sign the packages, right? So I will do a deep dive on how you can do that setup end to end. Also, I will do a demo on like how you can upload the cert to some Azure Key Vault as a secure service, and then download it during the runtime, basically doing the build runtime, and use that cert and sign the packages. Okay, so we'll cover like 3 steps. First, how to set up the pipeline. Second step, like how to sign the MPOS Apex file. Basically, when you build MPOS, it generates the APPX file. So I will show you like how you can sign that APPX file using the download file task. Because sometimes you may say like, hey, I don't want to use Azure Key Vault, but I want to securely. Sometimes the customer will procure the secure certificate, and then they don't want to share that cert, but they want to put that like in a say like a secure location. So I will showcase like how you can use the secure download file task, and then use that and sign the Apex file. Then the last step will show you like how you can use the Azure Key Vault to upload your cert and then download it during the build runtime and sign the packages using the Azure Sign tool. Okay, so with that, let's get into the demo. So I will walk through the sequence of steps to set up the pipeline. Okay, so first I created a new pipeline, and then the first thing is the agent specification should be like the VS 2017 Min 2016 for now, because MPOS will work only with the Visual Studio 2017. So if you choose some latest version, it may fail. Yep. Okay, so you'll do a create new pipeline and add these steps. Okay, so the first step is like there is like a pre-check build script which is already available in our sample source repo. So for example, here this is the sample repo we created exactly with all the sample code which Luke showed. Okay, and then there is a pre-build script, and this is also available in our GitHub public GitHub repo. So you can add this step. Okay, next step is we need to restore all the NuGet packages for your extension projects. Okay, so you can add a NuGet step. So you can click plus and then select like NuGet installer, and then specify what version of NuGet you want to install. Okay, and after, so once the NuGet is installed, basically what this pipeline does is like it's going to spin a runtime VM and it's going to install the NuGet in that VM. And then the next step is all this VM and everything is managed by Azure Pipeline. So you don't have to like set up a VM for this scenario. Okay. Then the next step is the NuGet restore. So you have in your solution, you may have like a different multiple extension projects, right? So for all those projects, you need to like restore the NuGet packages before doing the build. So that's why we are adding this NuGet restore step. Basically, the command here is like the restore. Okay, and then for which files you need, or like which project or solution you need to select do the NuGet restore. So you can put like start.solution so that it will browse through all the solution in your repo or like all the projects in your repo, or you can also like click and select like the specific projects you want. Okay, then the other important thing is like it's going to ask me like, hey, what is my NuGet feed? Okay, so if you select the feeds, either you can, if by default, if you select this one, what it will do, it's like it will try to find all the packages in the public field, in the NuGet.org, but some of our commerce package is not available in the NuGet.org. It's available in our own public feed. I think the URL, I think even in the Luke demo, you showed that URL, right? So that's why like I kind of selected like feeds in my NuGet config. So in our NuGet config, we added the location. You can find that location in the public docs. Okay, that's why I added my feeds from my public location. Okay, and then I selected my NuGet config. So here in my sample project, I added like the NuGet config. So here I have given that NuGet location to restore. So you can select that NuGet location. Okay, so far it's still like the kind of the basic steps where we are setting up the VM for ready to build. So we did like the install the NuGet and then restoring the NuGet for all the projects. Then the next step is like, hey, I want to assign my appx MPOS appx file. Okay, so for that, like my customer gave a secured file certificate, and I then want to store that securely, right? So you can add this download secure file task, and then click select, and then upload your the certificate file. Okay, so by this way, nobody will be able to download it. Even say for example, even sometimes the customer will not share the certificate with the ISVs or with the partner team, right? So in those cases, the customer can directly come to the pipeline and upload the file here, and so that nobody can have access to that file. Okay, you cannot like able to download or do anything with this file. Okay, so what this task does it like at runtime, it's going to place that file in the VM, and then immediately when the build completes, it deletes that certificate file, so that it's kind of like securely used only during the runtime. Okay, so now I added this file. So you can question like, hey, how this file is going to be used to sign the APX file. I will show that in the project. Okay. So one important thing is like you need to create a reference variable. Okay. This task has like multiple output parameters. So one is the secure file path. Okay. So then I added this variable, and then I can now get the file location using this variable. Okay. So for what I did was like I created a variable here. So for example, the certificate location, and then based on the reference value and then the parameters, I added this guy, signing the certificate location, and then the variable is like signing cert.secure file path. So now what if I go back to my repo, let me open this in the new tab. Okay, so if I go to source, I told like I'm going to use this for signing the Apex project, right? The modern POS. Okay, so if I go to the modern POS.js project, so here you can see like I have used that certificate location variable. So as soon as when you build this modern POS.js project, which is going to generate the appx file, that certificate location will be used. So that certificate will be used to sign your appx file. Okay. So this way, so if you don't want to use Azure Key Vault or something to secure your certificate, instead, if you want to like use something with the build pipeline in a secured way, then you can use this option. Yeah. So with that, I will go back to the build pipeline. Okay. So now I added this step to sign my appx file. Okay. Now the next step is like build all the different projects within your solution. So it can contain all your extension projects. If I show my repo here, so right, so it contains all my extension projects and also all the packaging project, the installer for the multiple installer we talked about, right? The scale unit installer, the modern POS installer, and then the hardware station installer, and then the cloud scale unit package, right? So all those packaging project and the core extension logic. Okay? So now in my pipeline, I'm gonna build all the entire solution. Okay, and then just the MS build version is 15 or later. Okay, and then I selected the x86 architecture. So now I'm going to build all this one. So what this guy does is like it's going to build all the project and then extensions as well as the packaging projects and generate the output. Okay. Okay. Now I built all the project and my output is ready. Okay. Now the next step is I need to sign all this installers generated and then publish it to the build artifacts. Okay. So now to sign the packages, I'm using the Azure sign tool. Okay. So you can ask like, hey, why I use the Azure sign tool? Because in this scenario, my customer like gave the certificate, or like you as a partner or ISV have your own certificate, right? And you want to secure that certificate, saying like Azure Key Vault or something, right? This step is not mandatory. You can use the So I think the signing step is, it depends. You even sometimes if you don't want to sign the installers, it's fine. Just you need to sign only the appx file. But I think most of the customer ISV partner want to sign the installer, right? So that you can, when you check the properties of the installer, you can make sure it's digitally trusted by the organization so that you can like safely install that application in your POS devices. Okay? So it's kind of like optional, but it's a highly recommended step. Okay, so you add the Azure installer sign tool. So this is just like a .NET Core installer. So you can specify like what components to install here in the sign tool. Okay, and for this guy, it takes like a bunch of parameters to sign. So for example, your Key Vault ID and then your cert file name, as well as the Key Vault URI and then the client secret. Okay. So all the steps are publicly documented. It's nothing specific to Commerce SDK, but I will quickly show you like how to do this one. Okay. Now I added this step, but before that, I need to put my certificate in my Azure Key Vault, and then also I need to like add apps to say that this is a trusted application. So I will quickly show you the Azure Key Vault setup. Okay, so the first step here is need to create your Key Vault to store the certificate. Again, the step is optional. It's more like if you want to do a secured way of your storing the certificate. Okay, so it's not like mandatory you have to like follow these steps. Yeah. Okay, so now created a new Key Vault here, okay? And then in the Key Vault, I added my certificate. So for example, for the demo, I created like the Contoso signing cert. I added like multiple certs. So you can say like you can create multiple certs and add it, or you can also generate the cert. Okay. So I added my cert here. Then in the access policy, now you need to say like, hey, which all application can access it. Okay. So before going to the access policy, so I created a new app here. Basically, you'll go to the app registration and create a new app, and then you get an app client ID, and then you will also need the tenant ID. So I created this new app, okay, and then you also need to create the client secrets. So here I added a Key Vault secret. So for this application, this is the secret. So using this secret, you can access this application. Okay. Then so I created this application. Now here in my key vault, I need to tell like which application can access this key vault, right? So if I go to my access policy here, so I added my signing app. So I've given like the permission. I think I selected all, but you don't need all. You just need the get list. And then here on the signing, you need get list. And then I think mainly the get list should work here. Okay. So you just need to select that step. So now I've given for this application signing app, I given permission to access my key vault. Okay. So now we will use this application in the Azure Sign tool so that it can download the certificate and then do the signing. So now I will go back to my pipeline. Okay. So here, if you now see, like I created a variable called application ID. This is the application ID used in my signing app. So if I go back to overview, so this is the application ID I created. Okay, I'm using that in my here, and then the key vault URI is this guy. So if I again go back to overview, so this is my key vault URI. Okay, and then the certificate location we already talked about. Then the certificate name is the one what you're using in your key vault. So in your key vault may contain multiple certificate, right? So what are the certificate name you want to use? You can provide that also as a parameter because these parameters are needed by the Azure Sign tool. Okay. Basically, those are the high-level parameters. The last important one is the secret, client secret. Okay. So for this app, I told you like I created the secret, right? Because only you will be able to use this app if you know the secret. Okay. So you can take this secret value and then put it in your pipeline. Okay. Now you can wonder like, hey, how these values are used, right? So I will go back to the pipeline. So I added the sign tool step here. Okay. Then the rest 4 steps is like when I do the build, it's going to generate the following outputs, right? The cloud scale unit package, and then the modern POS installer, the hardware station installer, and then the cloud scale unit self-hosted installer. Basically, what this copy step does is like it takes from the build output and then just publish it to the staging directory. So that in my pipeline, after the build is completed, when I go to the pipeline, published artifacts, I can see it. So basically, we are copying it to the staging directory. Okay. After copying to the staging directory, now we're gonna sign all these 4 files in the staging from the staging directory. That's where now I'm gonna use the Azure Sign tool. So we created like a custom PowerShell script. Either you can use the script or you can even directly call the Azure Sign tool from the step. Okay. So here now I'm saying like I'm passing all this parameter, the tenant ID, the application ID, the secret value, the certificate name, and then the timestamp to sign the files. Okay, and what all the files I need to sign. Say for example, all the installer exe I need to sign. The cloud scale unit is just a zip package, so you don't have to sign that. Okay, I'm just signing all my installers here. Okay. So now if I go to this, also I will start queuing this, run this pipeline so that you can see the output demo. But I will still continue explaining the pipeline stuff. Let me go back to the pipeline. My pipeline is still running. Okay. So now in the sign tool, I talked about like we added this code sign PS1. So what this guy takes is like the Azure sign. It's gonna call the Azure sign tool and pass all these files to do the signing. So if I go back to my source here, and then in the pipeline, this sample file, all the sample files are available in the public GitHub repo. So for example, if you see, it takes all these parameters, okay, and then it calls the Azure, this PowerShell calls the Azure sign tool by passing all the parameter we call, and then at the end, it says like these are the list of files to sign. So you can check the Azure sign tool public document and see like what all the parameters it can take. So basically the timestamp ID, there's like a detailed doc available publicly, so you can see how exactly this tool works and why we need to pass all this parameter. Okay. So now if I go back to the pipeline, so after the build, we generate all this. Now I'm signing all this file from my certificate stored in the Azure Key Vault, downloading those files, and then I'm securely signing. Again, the steps is optional. Don't think it's like I need to put the cert. It's more like how to do it in a secure way if you don't want to. In the old retail SDK, if you've seen, the certificate was like locally available in in the build tools, I think the asset or the build tools folder, which is not like a secured way for developer demo purpose, we added that certificate. But in real world, your certificate may be coming from your cert provider, or it will be like your customer maybe say want to securely store it, right? That's why we added this step. Okay. So now when the pipeline runs, it will call the sign tool, sign all the files. And then the last step is like publishing it to the artifact location, so that once the build is completed, then you can download all the files. Yeah. Okay, I think we already triggered the build. Let's see what is the stage it is. So it's kind of like doing the NuGet restore, and then now it's running the pipeline. So it may take like, I think total it will take around like 3 to 4 minutes max, but I already let it run. I already like completed like few runs. So we can go to the completed runs. Yeah. So again, I didn't show you like how to set up a release pipeline. So now we did all the builds. Suppose you can also set up a release pipeline and then say you want to publish it to the LCS to upload those packages, right? So you can also, after a build pipeline, you can set up a release pipeline also. I think this step is already documented in the public doc, so you can later refer it. Okay. So now if I go to my previous run, say for example, last night I did like few runs. Okay. So you can see like the job completed successfully. And then if I go to the published artifacts in the jobs, so you can, one second, you can see like all the different installer, you can all rename all this. So if you see generated all the different installers, and then all the, so this guy will have the cloud scale unit packages. Okay. So now if I download this installer, I already downloaded that installer. So if you see that installer, and if I right click and see the properties here, you can see the digital signature, like it's signed using that certificate, the custom certificate I used, and then you can see the timestamp. I think for the demo I tried it last night, so you can see that particular timestamp. It's like properly signed with whatever the algorithm we said, the SHA-256, and then now the installer is properly signed. Also, the Apex you will not be able to check the Apex, but when you install it, you can see like it will be properly signed with that certificate we used for the API, the Apex file signing also. Okay. So with that, I will go back to that build pipeline. Hopefully it should have been completed by now. Yeah, I think it's successfully completed. I think the output will be the same. So it takes around like 4 minutes. Okay. And then if I now go to the build artifacts, I can see all my packages successfully published, and then I can download it. And as I said, like if you want, after the build is done, you can trigger a release pipeline and then upload it to the LCS. Even we are working on publishing the package to the Commerce environment, so that you can even do a deployment from the build pipeline. So that it will be an end-to-end CI/CD pipeline. Yeah. Okay. I think the job successfully completed. So it's exactly now my artifacts is available. It ran successfully, and then you can download the packages. Yeah. Okay. So I think this is what exactly I showed you. So you can now set up end-to-end pipeline for doing your CI/CD. Yeah. So I will go back to the deck. So we showed the demo. Now I will hand it over back to Luke to show the VS 2017 build agent setup.
Thanks, Maganthan. I'll quickly walk through now the steps to create the custom build agent in Azure DevOps for MPOS packages. So just briefly, I know Maganthan did a very good job of giving the background info previously, but with MPOS's requirement for Visual Studio 2017 to build and produce the packages, and Azure DevOps is removing support for Visual Studio 2017 in the hosted agents in March, we need another solution to build MPOS extension packages in Azure DevOps pipelines. And so these are kind of the simple steps that I'll walk through next on how to create that custom agent. These steps will only be required, I guess, if you're building MPOS customizations for CloudPOS or any of the rest of the Commerce SDK components wouldn't require this custom VM. So the first step is to create a new VM in Azure. So just simply going to the Azure portal using the create new VM functionality that it shows on the left here. You can use pretty much any Windows image for. I would recommend though the Windows Server 2022 data center image. You can see that on the right here. And so that's pretty straightforward. So then once the VM is created in Azure, the next two steps are basically to install the development prerequisites on the VM. The first one being Visual Studio 2017 with the components on the right. And those components are also listed in the documentation on the doc site, and that's also shown here and linked on the additional resources section of the background info slide. So if you're looking for that documentation, that's one quick, easy way to find it. The third step, second part of installing development prerequisites is to just install the .NET Core 3.1 SDK and .NET Framework 4.7.2 on the machine. Pretty straightforward, just using the installers you can download from the .NET site. So I've actually already completed those 3 steps for the sake of time for this demo. So what we can see here is the Azure DevOps agent that I created in the Azure portal. And so this is just a simple Azure VM that is going to be configured to be a DevOps agent here shortly. So we'll walk through the remaining steps to set this up live as a part of the presentation going forward. So the next step in this process is to create a personal access token so that we can use it when we're configuring the new agent. So I'll go ahead and say DevOps access token. The expiration isn't very important. You can set it to a short period of time because the token isn't used in the daily operation of the VM. In the agent, it's just there to set up and configure the agent initially. So a short time window is probably the best option here. So the scope that we need to set is for agent pools, read and manage. And that's it. So we'll say create. And that'll create our personal access token. And so with that step done, the next thing that we'll do is we'll go to actually download the agent. And for that step, we need to actually go to the machine. So you can see here that I'm remoted into the Azure VM here. So now that I'm in this, we'll go to DevOps. We'll select our organization. So here under organization settings, and then agent pools, and then the default group. So we can see here we don't have any agents, so we'll go ahead and say new agent. First step to do is hit download the agent. Okay. So that looks like it's downloaded. And the next thing we'll do is we'll open a PowerShell window as admin. Go to the root. And then we'll want to follow kind of the steps that they give here. So that's basically to make a directory for the agent. And then we'll go into that directory. The next step there is going to be to run this command, which will basically unzip the agent into our current directory. This should only take a few seconds here, and we can see it working live if we go in the File Explorer. Okay, so it looks like that's done. So then the next step, now that we'll do that, again, we're following kind of exactly what they're saying here, is we'll just go ahead and run the config command. So config. So we'll want to enter the server URL. And so the server URL here is just the path to our DevOps organization. So in this case, Commerce Solutions organization. And now we'll go ahead and need to enter that personal access token that we got from the previous step. So let me copy that in here. Okay, so now it's connected to the server. It wants us to go ahead and register that agent. Do that. We'll keep the defaults for the pool and the agent name. And now it's all handled as a part of this kind of PowerShell wizard provided from Azure DevOps. So whether or not to run the agent as a service, I would recommend to run the agent as a service, and that's the recommendation from the DevOps team as well. We can keep the default for the service account. We can let the service start when the configuration is finished. Yes, so we can see now our service has started successfully. So if we come back here, we can see that we have our agent showing that it's offline, which is something that we can address if we go to services. And what was that called? The STS agent. Let's see if there's an option in the UI. No, okay. Either way, I'm not quite sure why it's showing as offline right now. It may just be a matter of refreshing that. But we can see the agent is defined. Yep, there it is. Now the agent shows as online. So it's just a matter of refreshing the UI. So with that done, we can quickly go over to the repo, and we can go to the pipelines, select our build pipeline, edit, and then go ahead and change from Windows latest in the Azure Pipelines pool to use our default pool, and then save it. And then now if we kick off a build, it'll use that Azure VM to run the pipeline, and that way we can ensure that all of the required prerequisites are installed. So with that said, I think the next thing we'll quickly run through are some key takeaways from this session. The first key takeaway being about the packaging projects, how they're used to generate the installers for the extensions using the new sealed installer framework, as well as generating the Cloud Scale Unit extension package. All of that, again, handled through package and project references to make it easier. All of the independent packaging components support multiple extension packages, and that's the recommended approach, is to install and update all extension packages separately for the on-prem components. For the Cloud Commerce Scale Unit today, we went through the steps to merge the packages as a part of the build. This is a kind of shorter term solution to streamline that process while we're working on the longer term solution to support multiple extension package deployments in the cloud. Lastly, we went through the steps to create a Visual Studio 2017 build agent to create for MPOS packaging. Sorry about that. So yes, Visual Studio 2017 build agent for MPOS packaging and building any Commerce SDK solutions that contain MPOS extensions. So with that, I think we can, one last thing, we do have 2 more tech talks coming up as a part of this series. The next one is on January 12th. It's a deep dive into hardware station extensions with the Commerce SDK. And then the last tech talk as a part of this series will be a deep dive into Commerce Runtime and Headless Commerce extensions and how to migrate them to the Commerce SDK. So with that, if there's any questions, we can take those now. And as we've done in the past, we'll be sending out the Q&A doc after the event for any questions that we didn't get to answer during the call today.
So look, I think most of the questions are answered. So I think we have only 1 or 2 questions left. I'm replying to that. Look, so we are good and we are also on time. Yeah.
Perfect.
Thanks everyone for joining the session. Back to you, Emily. Yeah.
Thank you. I've posted a link to a short survey in the Q&A panel. We'd like your feedback on today's session and to hear what you'd like to see in future events. Thank you for your participation. As a reminder, the recording of today's session will be available on the Tech Talks Community Dynamics page within 5 business days. I'd like to extend a big thank you to our presenters and audience for joining us today.